do, could you name like an object-oriented programming language? Anyone? Java is not object-oriented, by the way, but yeah. Any other? Yeah, Smalltalk is object-oriented. Erlang is object-oriented. Perfect. Yeah. Any other? No, C++ is not object-oriented. Ruby is not object-oriented, by the way. Python is not object-oriented. I know only Smalltalk and Erlang, but and do you know who coined the term object-oriented? It was Alan Kay when he worked at Xerox laboratory in the United States. And do you know the definition of what does it mean to be object-oriented? Like, what's the definition of?
You get objects that communicate with each other by synchronous action and change data by asynchronous.
Excellent, excellent. That's the definition. And what's important here in this definition, which Alan Kay gave, is this word asynchronous, which means that Java is not object-oriented because we have null pointer exception. It's not asynchronous, right? It means that there are objects which are independent, like actors in Erlang, for example, which communicate in an asynchronous way by exchanging messages. So it's not like function invocation, it's like message passing. So this is important. And later, people added things like inheritance, polymorphism, etc. But it's not really like the fundamentals of object-oriented programming. Okay, so my name is Kuba, but people know me as Zaiste, and it goes back to like Solaris times when I was working with very old computers, and I had this limit of 8 characters, and I had to come up with a username, which was like short and easy to memorize, so it was Zaiste. I also organized a conference called PolyConf. So today I have a surprise for you. We'll be raffling a ticket to the conference, what you need to do is to retweet a tweet I just posted on our Twitter. So it's PolyConf HQ. And if you retweet it, you will enter the raffle. So at PolyConf this year, we will have, for example, Douglas Crockford, creator of JSON format and the guy behind the book JavaScript, the Good Parts. We will have Andres Stouts, who created Cycle.js. We will have Guy Bedford, who created JSPM, package manager, and many other interesting speakers, so I highly invite you to join us. So in this talk I will tell you my story of programming and how it started, and this will be like a particular angle. So it started, and the story starts in 2005, and I was using at that time mostly Java, like very heavy enterprise stuff, working like financial things. And then I moved to Paris, and I started working in this laboratory, artificial intelligence laboratory, and I started using Python. And when I was in Paris, I also was exposed to functional programming for the first time in my life. And it was very difficult for me, because till to that point I didn't really know what functional programming means. So we all know that functional programming is about functions, right? Functions are first-class objects, but there's more to this. For example, we can talk about laziness, we can talk about referential transparency, we can talk about immutable data structures, about structural sharing, and all that stuff, which is very interesting. So I got exposed to functional programming through a language called OCaml, which is a very interesting language. And I worked with Marc Pouzet, which is one of the contributors to this language. So what's OCaml? OCaml is one of the languages from the ML family. And ML family is one of the oldest programming families we have. So it's like Lisp programming languages, and then there's ML. So ML was created in 1970s by Robin Milner. And ML still has a lot of influence today. For example, when you program in Haskell, recently when you're doing front-end of Elm, for example, there is a lot of ML inside those two languages. Okay, so let's talk now about UIs, because we are like here at Frontownia, and UIs is what's really interesting for us. So to talk about UI, we have to talk about human-computer interaction, right? And we can see human-computer interaction as a way of like a dialogue, right? There's a human and there's a computer, and they are in a constant dialogue. They exchange information. And we can say that they observe each other, right? Because we humans, we have eyes, and we observe computers, and computers observe us, because they like take inputs, like we move our mouse when we type something on the keyboard. So those two entities like observe each other. It's very important. And this idea was formalized in 1970, similar to when ML was created, by a guy called Tryggve. And it was named Model V Controller. And I hope most of you know this pattern, right? And Tryggve formulated this idea when he was working again at Xerox for doing a research for a language called Smalltalk 76. So when he introduced MVC, he wanted to help like bridge the gap between the digital information and the user mental model, right? Because computers have digital information inside, and we have like a mental model of what we want to achieve. So MVC is to bridge the gap between those two things, let's say. So when we see like typical MVC diagram, we have the user somewhere, and we have those three things. We have view, we have model, and we have controller. In this view, we could say that the model is the subject, and the model is observed by the view, right? Because when we want to change something on the view, we need to observe our model or data and react to this, and then we change the view. But typically, what we do today, like most of us, is that we use this approach called callback-based, which is very bad, because we have those. We have to manage somehow the signal between the user and the computer, and we have those callbacks, right? And we attach them to different things. And when we do this, we say that the control flow of our program is like scattered in many places. And again, when it's the case, there's also this thing that we don't really know when the events will occur. So we don't know how to coordinate these things. Additionally, the data we have needs to be exchanged through like shared state or through side effects. So it's not very good to reason about this kind of things. So imagine, for example, you have a bunch of children, right? And would you prefer to like handle the children which like scream and run and push one another, or would you prefer children who are like well formatted and they like keeping their hands like that and going into one direction? I think it would be easier. The second approach would be easier to handle. So that's why callback based is not really good, and all that jQuery stuff we do is very difficult to reason about. Okay, so let's talk now about how we could apply functional thinking to building user interfaces. So the first, this idea, this functional programming applied to UIs was mostly put into mainstream thinking by React, because what React did, it said that our UIs can be declarative, which means that we don't have to specify how things work, but we can specify what they should do, right? How they should, maybe how that's not a good word, but what it should look like. And we could start thinking about our UIs as a function. So we could say that UI is basically a function of our state, because every time we change the state, there is like a new UI, new view that needs to be generated. And React, because of that, React introduced another interesting concept. So let's say that UI is a function of state, and we have some data, d0, and our function transformed this into view. And then later we have some other data, like d1, and we have another view that's generated, v1. So what we can say is that we can like compare those views, and we can say, well, it's quite similar. There's only like a bunch of things that needs to be changed to like migrate from V1 to V0 to V1, and that's how virtual DOM was introduced in React, like a side effect of these side effects in a more common sense to this functional thinking. So in React, it's very simple, right? We have data, then we transform the data, and we have this virtual DOM, and then we apply our virtual DOM changes to our real DOM, which is very costly. But then again, it's not that simple, because when you start programming in React, it becomes really difficult, right? Because you have a lot of new concepts being introduced. You have action callbacks, you have, action creators, you have dispatcher, action, store, and these things, these are new concepts, right? You have to learn them. It's not like what you already know. It's quite different. Okay, so let's talk right now about reactive programming. What is reactive programming? So reactive programming is programming using asynchronous data streams. So I will repeat this because it's important. So reactive programming is about asynchronous data streams, right? So we have something which is asynchronous, we have some data, and then we form streams out of this. And I think most of us here already did a lot of reactive programming. And why is that? Because a spreadsheet is like a reactive programming tool. And who used spreadsheet in his life? Anyone? Okay, like most of us, yeah. So if you worked with spreadsheets, you know how reactive programming like work to some extent. So let's take a cell in a spreadsheet, and we can say that this is like a value which changes over time, right? Because we don't have to worry how this change like goes into this cell, because we know that spreadsheet has this particular way of working. So when we have two cells and we combine them, like we do the sum of them or we subtract those numbers, we expect that this resulting cell will update itself, right? We could say that the cell is somehow we can observe the cell, it's observable. So let's talk right now about how two things can interact with one another. So let's say we have entity A and entity B. And typically, we could say they are two things, how those entities can interact. There is a passive way, which most of us use probably, when A invokes a function on B, right? When we want to change something, in B, for example, we invoke a method, let's say if it's an object on B. And this is called passive because B is not really aware of the arrow. The change comes from outside, and B doesn't really know when the change occurs. But there's another way, and it's called reactive. And reactive means that B reacts to something. So let's say B knows, B is notified about something that A wants to do. And B says, well, I want to change myself, reacting to this event. And this approach is better, because it means that A and B are separate. There's no really connection between them, and we could say that there is a clear separation of concerns here. And another thing is that in programming, very important concept, it's encapsulation, right? So B doesn't expose its state externally. B knows how to change itself. There's no one who changes a B except B. So reactive approach is this approach when we separate concerns and module focus really on their own functionality. We can also say that data streams, we can think about them as values over time. So if we take this concept into like first class, we could say that we could observe changes in our streams, we could combine changes together, and basically if we would like to name this concept, like concept of values over time, we would say this is something which we could observe, which is observable. And observable is this combination between observer pattern, like most of you already know, and iterator pattern, or you already know iterator as well. So if you combine those two patterns, you have observable. So we have a sequence of data, and we have functions that can combine those sequences, and then observable abstracts, which is very important, some very like low-level things, something like synchronization, like thread safety, concurrent data structures, non-blocking I/O, etc. So if you program using observable, you are like more secure than using traditional approach. So this is a marble diagram. So I won't dwell too much on this, but these diagrams show how observable looks like. So as you can see, it's just an arrow with some points on it, and it's points that occur over time. So observables have very interesting properties. So one of them, which is also somehow related to functional programming, is that they can be treated as lazy streams. And lazy streams means that we don't have to consume our observables like immediately, right? We can wait. We don't have to ask our computers to do computation for us. If we can wait, observable can wait as well. Another thing is that they introduce asynchronicity in a very easy way. So if we imagine that we have tasks and we can theoretically like separate those tasks using this reactive approach, you can like the longest task would take, like the whole computation would take that far, like the longest task in our set, right? I'm sure it's clear. And because of the streams that can be combined easily. Observables also like introduce this declarative approach. So we focus rather on what and not on how. So we don't have to define like iteratively what needs to be done. We just say, well, we have to do those streams. I want to combine them. I want to do some functions on them. So it really shows the flow. It's very easy to read the code, and it's very easy to reason about. And it's very simple composition as well, like functions or like pure functions in functional programming, when you just combine streams, and this is the only thing you can do with reactive programming. So on top of that, observable introduces this unification. So you don't have to use promises, you have observables. You don't have to use callbacks, you have observables. Web workers, well, you have observables. WebSockets as well. There's observable for everything. So you have like one simple abstraction you can use. So reactive programming existed for a very long time, and there is this this set of things, this library, sorry, where called reactive extension that exists for all programming languages. And there is also RxJS, which introduces some it's library to do reactive programming in JavaScript, basically. So let's take a look at example. So this is very simple reactive code, and what it does, it just detects double clicks. So I challenge you to write this code as concisely in JavaScript. I think it's going to be much longer to write. And let's maybe quickly analyze this code. So what I have here is click observable, and it gives me the clicks over time, right? It's a data stream, asynchronous data stream, and I get the clicks. And then I say, well, I want to buffer those clicks in a time frame of 250 milliseconds. And when I buffer them, I have like sets of those clicks. And I'm only interested in the sets which contain 2 clicks. and then I count. And as you can see, this piece of code also detects, like differentiates between double clicks and triple clicks, right? Because triple clicks are not included here. And it's very easy to, like, you can only glance this code and you see immediately what it does. And as I said, it combined the things. So we have observable, we did some transformation, we have another stream which is generated. On this stream we do another, apply another function, etc. So it's very simple. Okay, so now let's combine all those concepts I introduced. So functional programming, reactive programming, and we will, well, the conclusion would be something like Cycle.js. So there's a guy called Andres Stouts, which combined those concepts, which is very interesting. And he created Cycle.js, which is functional and reactive UI framework in JavaScript. So Cycle.js is interesting because it's very concise, and you can easily build application with this, and it has very simple API. There's one method in the API. It's called cycle run. You have nothing else. And so let's maybe go back to the first diagram when I talked about human-computer interaction. And here it's more elaborate, and you can see that we can say that this interaction can be thought as a function between the input, the output, and we have computer, right? Computer could be a function. It's a function of input devices, like taking things from keyboard, mouse, and generating some views on the screen. And then human could be a function as well, because we have senses, and we have things to act on other things, like we can use our hand to grab the mouse and do something, or we can type with our finger. So we have senses and we have actuators. And we could say that UIs are cycles, because they're constant cycle going on through our main function. And what's interesting in Cycle.js is that main is pure function. And pure means that the function doesn't have side effects. Okay, so let's take a look at this function. This is computer function, and we have some user events observable. And we take this observable, we map those events onto something, we filter somehow using a predicate, and then we transform it to some pixels on the screen. And in Cycle.js, we have two other abstractions which are important. And the first one is called sources. And sources are the inputs. So we somehow push the side effects to externally. Because our main function is pure, we cannot have side effects inside this function. So we have to push this somehow. And we introduce this concept called source, when we grab, for example, clicks of the mouse or keyboards, and this is our source. And for example, in Cycle.js, we can have DOM source, or we can have HTTP source, and all those sources give us some events. And we have also sinks. And sinks is when we put things, right? So when we do some computation, we just put things to our sink. Let's call this DOM sink, and this DOM sink just generates something on the screen. And within our pure main function, we interact with sources and sinks using drivers. So drivers are basically something which helps us to interact with those two. And Cycle.js introduces somehow slightly modified view on how things could interact, and it calls it model view intent. So first, we have intent. So intent is what someone wants to do. So in this example, when we had this user observable, user has some intent. He wants to click on this icon, or he wants to type this word. So this is intent, and we analyze the intent. We transform the intent of the user into a model, into our data. And then we transform the model into the view to react to those clicks or those keyboard typing. Because main is pure function and there's only one function, it's extremely easy to compose those functions. So being composable is out of the box here. So I don't have much time, but I will quickly show you some demos. So this piece of code, this is our main function, as I said. And here we have our sink. We say the DOM is our sink. And we have observable, which generates like an event, like a random event each second, and transform this into our view. So what it does is that we have a counter which increments, right? Very easy. And let's take a look at another example, which is more complicated. So again, we have main, we have sources. So through the sources we communicate with our drivers. So we have this DOM driver, and this DOM driver generates some events. And we are only interested in events on the field with the class, with the selector field. And we take those events, we transform them into values. We also say that the stream should start like an empty. And then for each like typing into our input, we generate the input again, saying hello, what we already have. So this is basically what like this typical Angular demo shows. When you have like an input, you type something, and immediately it shows a thing on the screen. And it's very, very concise, as you can see. It's only like a handful of lines of code. Okay, so to sum up, Cycle.js and reactive programming, functional reactive programming, first of all, it's functional, and we have pure functions. We can combine them. We can create our UIs in a more efficient way. Our functions are referentially transparent, which is important characteristic, and it's also reactive. So we use observables to manage our event management. We don't have callbacks attached to different things on our like web page or something like that. And observable is a nice abstraction because we abstract things like promises, WebSockets, and all that. We can use observables for that. Yeah, so that would be all. And if there are any questions, I'll be happy to answer that. Anyone? Yeah.
There was a code about observing typing on input.
Yeah.
And I wasn't really sure what really event are you here listening at, because there are just events on input, so all events like clicks.
No, I'm only interested in, I'm only interested in input things, so it's only keystrokes.
Okay, so the input are the types of
events.
Okay, that's fine. That's fine.
Okay. Any other question? Yeah.
Did you try to use some bigger project?
No, I think it's not suitable for production code. I think it's interesting, like intellectually. I wanted to share this with you because I think it's it's like kind of curiosity how things can be made, but I don't think it's really ready to be production. It is wise to use it in production, and people in Cycle.js understands who will be coming from Finland to Polyconf. They're working hard to make it production ready. So they like take ideas from React, other stuff, but right now, no, and I haven't used it in production. I just toyed with this, but it has very interesting ideas. Yeah.
Question, but what about testing?
Yeah.
Are there any frameworks or something like that?
So, like in functional programming, when you deal with functions only, like if you use, for example, Redux with React, and you stay you want your code to be functional, you only have functions. Like the main things done in your code are functions, and testing functions which are pure is very easy. It's like basically because you don't have side effects. So always when you give some input to this function, you will know that this output will be generated. So if you focus on doing things in a functional way, like most of your problems like go away, because most of your things is functional. But the rest, like let's say 80% is It's functional, and you can like easily write. You don't need a framework for that to write tests. These are only functions. And the rest 20%, it's more difficult, obviously, but I haven't checked this really into much details. Okay, any other one?
Do you know some real-life products which use React?
React?
Yeah.
You mean Cycle.js?
I mean real-life projects.
Reactive programming, you mean?
Yes.
Yeah, so reactive programming is very old, and it's, for example, one of like my favorite companies is Netflix, and Netflix is very like good on the front-end things, and they use reactive programming extensively. So they are a major contributor to RxJS and to other like reactive programming stuff. And there is two guys I recommend: Ben Lash, who I tried to invite to Poznan, but he was maybe he will come next year, and Jafar Hussain, and they work on Netflix, and they show how they transition from like typical programming using JavaScript, callback oriented, to like reactive. And it's very interesting, and they scale because Netflix is like huge. They're doing very interesting things with reactive programming. Okay, so I will, yeah.
How would you compare React.js to reactive programming? Is it like they try to implement reactive programming in React.js, or is it just a poor version of it, or something completely different?
You mean the React and reactive programming? So React is not really, it's only the name, right? React is not really like reactive. So React and reactive, these are like two different concepts, just to, and I don't know, the name React, I don't really know why they call it React, really, to be honest, but I have to think about this. It never occurred to me to, but reactive programming is more about this, like when I compare those two objects, A and B, is that you don't really like push someone to do something, but the thing reacts to something. Observer pattern is that, and there you have observable and all other abstractions to use that. Yeah. Okay, so I will stop here. Thank you very much for listening, and grab me later.
Wielkie dzięki Jakub za fajną prezentację. Chyba przejdziemy teraz powoli do rozwiązania naszego konkursu.
Rozwiążmy nasz konkurs.
Może tak na szybko podnieście ręce wszyscy, którzy tutaj zatweetowaliście. Ilu was jest?
Okej. Czy macie jakiś pomysł, jak można nas losować? Jakiś programistyczny, ktoś zna programowanie i mógłby napisać program? Dobra, ja muszę się podłączyć do internetu, nie mam. I sprawdzę tylko, kto... To może, nie wiem, jakąś liczbę ktoś rzuci. 25, 13, to jest 38. 66, 45, dobra, to jest trochę dużo. Dodajmy te cyfry, to jest 9. 9. osoba, która tweetnęła, będzie wygrać bilet. Czy to jest ok dla was? Dobra. Możecie zobaczyć, kto jest 9. Jeszcze się łączę.
Wydaje mi się, że to było dosyć wysoce randomowe, więc...
Mogę się podłączyć do siebie. Także suspens. Dobra, mogę zobaczyć. Normalne jest. Spróbuję z telefonu może. Okej, dobra, mam to. 18 osób kliknęło, 9. osoba. Paweł Wodkowski.
Nie, no gdzie ja?
Nie, Paweł nie może, bo Paweł
mogę, ja
pracuje ze mną i ma już bilet. Ode mnie, także...
9 plus 9 to 18.
No dobra, 18, czyli 9. Nie, dobra, okej. Jeszcze raz może, żeby było...
Polska jest gdzieś na pewno jakaś taka aplikacja.
No masz random,
Tak? Dobra, kolega tutaj narysował. Od 1 do 18, tak. 1. Joanna Wójcik. Brawo. Dzięki wielkie. Brawo.
Okej, w takim układzie prosiłbym Joannę, tak, o kontakt z Kubą po tutaj już naszej prezentacji. Okej, no w sumie to była nasza ostatnia prezentacja na dzisiaj. Bardzo technicznie. Mam nadzieję, że taka zawartość naszych spotkań też Wam się podoba. Raczej staramy się żonglować tą tematyką. Dawno już nie było takich mocno technicznych tematów, więc w tym momencie postanowiliśmy takie tematy zdobyć dla Was. Oczywiście czekamy na Wasz feedback. Piszcie do nas, czy to na maila, czy gdzieś przez Facebooka. Jeżeli możecie też jak najbardziej pisać do nas o tym, czego byście chcieli posłuchać na naszych spotkaniach. Potencjalnie będziemy wtedy wówczas starali się poszukać prelegentów, którzy będą w stanie dla Was to wygłosić. Dzięki wielkie za przybycie. Zapraszam Was jeszcze do skorzystania z naszego skromnego bufeciku. Coś tam pewnie jeszcze zaraz dorzucimy na ruszt. Dzięki wielkie jeszcze raz za przybycie i do zobaczyska następnym razem. Następne spotkanie, myślę, będzie... Może zrobimy tak jak w poprzednim roku, coś wakacyjnego, czyli w sierpniu, ale to będziemy Was z dużym wyprzedzeniem informować na Facebooku. Dzięki wielkie.